Hey everyone, it is section 10.2 today, areas of trapezoids, rhombi, and kites. So first with the area of a trapezoid, got another formula, but before we just dive into the formula, I want to do a little exploration with it. So let's say we have this trapezoid here, you can see, and this trapezoid has the two bases, one called base 1, one called base 2, and we have a height here which is perpendicular to actually both bases, and it has to be perpendicular to both because the bases, remember, are parallel. So if I take this trapezoid and I just draw an identical trapezoid in next to it, I'm going to try my best to draw it. We know I'm not the best at drawing. And if you just pretend with me that this trapezoid is exactly identical, but basically we just flipped it over. Okay, so this here, base 1, is really down here now. So on this one we have a base 1, we have a base 2, and we would still have the height coming through the middle there. So if we have this, then we would know that this side over here and this side over here are the same exact side, because this is the side that would have gotten flipped over to here. So that means those sides are congruent. Well, if we add base 1 plus base 2 to get this full side, then that's going to be the same one as adding base 1 and base 2 to get this full side as well. Meaning this big long side on the top and bottom, the base adding together, would also be congruent to each other. And now we can actually see that this whole big shape, which I'll do in blue here and kind of erase my arrow, this whole big shape is a parallelogram, similar to how we did the triangles. And so similar to how we did the triangles is we said, okay, well, the area of a parallelogram for a parallelogram was base times height. Well, this trapezoid is a little bit different here, because now instead of just the base being one of the bases, it's actually the bases a base 1 and a base 2. So as we start kind of coming up with our formula, we're going to have base 1 plus base 2, and that's going to take the place of just the base in the area is equal to base times height of the parallelogram. Then we would still have the height, because in a parallelogram you would need the entire base times the height, which is still going to be h. And similar to the triangle, we don't want this entire thing. Rather, we actually just need half of it. So we end up having the area equaling 1/2 base 1 plus base 2 times the height. So we're going to use that formula to help us with example 1 here. So example 1, we have a trapezoid. We're told one leg is 7, another leg is 5, one base is 6, another base is 8, and we have a height here of 4. So for our formula, once again, area is equal to 1/2 base 1 plus base 2 in parentheses times the height. So we need to know base 1, base 2, and the height. So base 1 and base 2, which one's which doesn't matter. As long as 1 is 6 and 1 is 8, either order is okay. And the height has to be 4 because it's the distance between the bases and it's perpendicular to both bases. So we plug all these numbers into our formula. We end up getting area is equal to 1/2 6 plus 8 times 4. So we have to do the addition here before multiplying that with any other number. So we end up having 1/2 of 14 times 4. And if you multiply all of those numbers together, we end up getting the area of this trapezoid to be 28 square of whatever units we have. Because it's not specified, so we can't say it's square inches, we'll just say it's 28. For our next example, we need the area of a rhombus. So this is going to be another formula, and I don't have an exploration for us this time. What we're going to do is going to be area is equal to diagonal 1 times diagonal 2, where D1 and D2, like I said, are the diagonals. So in this rhombus over here, the only things we need to find the area of the rhombus are the two diagonals, and we're told one diagonal is 12 and the other diagonal is 16. So if this is diagonal 1 and this is diagonal 2, order does not matter. When we do area is equal to d1 times d2, we take our area and have it as 12 times 16. So as we take 12 times 16 centimeters, we end up getting 192 square centimeters as our answer for the area. Next, we have the area of a kite. The area of a kite is actually going to be the same exact formula. Area is equal to d1 times d2, where they're the diagonals again. On this kite, this one's a little bit different because instead of the whole way being across 3, we're told it's 3 and 3, making one of the diagonals 6 meters. The other diagonal would be the 4 plus the 9 to get us 13 meters. So as we plug those into our formula, A is equal to d1 times d2, we end up getting area is equal to 6 times 13. And that gives us a final answer for this one of area is equal to 78 square meters. And we're already done with the notes now.